As we start to look at the logarithmic graphs, you have to first understand that these are the inverses of your exponential function. So if I have 2 to the x, if x is 0, I'm at 1, and if x is 1, I'm up at 2. So you've got these two ordered pair points. And what happens is, as we think about the idea that this is an inverse, we have to invert these ordered pairs. So instead of being at 0, 1, I'm going to be at 1, 0. And instead of being at 1, 2, I'm going to be at 2, 1. So the original exponential function that we've been working with all along goes like this. And our logarithmic will go like this. And of course we have that these are going to be a reflection across the line y equals x. And then we need to distinguish some things. So as a review, our exponentials have a horizontal asymptote. We have a domain of everything and a range that is not everything, because the range is cut short by the fact that it doesn't go across the x-axis in its parent location. So as we talk about our logarithmic functions, they don't have a horizontal asymptote. It's going to end up having a vertical asymptote. Now in this parent location, the vertical asymptote is the line x equals 0, because it does not cross the y-axis in this parent location. So then the domain for this is not everything, because I do not ever hit the the y-axis. So the domain comes from 0 to infinity. The range, however, is not restricted in any way. Any questions about that? You need to see me. So for this next example, you've got a graph given to you, and you have a red, a green, a blue, and a black graph that are given. Notice for me, please, that the green and the red are both going to be exponential equations based on the shape of it. And then that leaves the blue and the black to be your logarithmic equations. All right, so that kind of dictates which one goes with what. So if I look at this, I have e to the x, which is a base of roughly 2.7. I'm approximating. And then this one is 10 to the x. So I know that if I have 10 to the x, this one is going to increase very rapidly. Okay, so it's not going to take it very long to shoot up very, very dramatically. So that's going to be the green graph. And then that only leaves e to the x to, of course, be your red graph. So then I'm looking at natural log and log. So again, natural log is going to have a base that is a base of e that's understood right here. And then log with nothing written is a base of 10. So as I look at this, I am literally just going to be taking the red and green graphs, and I'm going to be reflecting them across the line y equals x right here. So the green graph is closer to the y-axis in the green location, and the one that's going to make that happen down here would of course be the black one. So green ended up being 10 to the x, so this one is going to be your black graph because it's closer to the x-axis when I invert my ordered pair points. And then that leaves the blue one, of course, to be e to the x. You can check these on Desmos, obviously on a quiz day, homework day. You could use it on a quiz day, you cannot. So you have to understand that inverting these across the line, y equals x, that axis of symmetry, y equals x, you still have some of the same qualities. So you have to be careful to put that together in an understanding about the graphs. This next one is giving us 4 different graphs that we need to graph. Now these, when you do the problem, are going to have 4 graphs that you're choosing from. Rather than try to copy and paste all that here, I'm just going to talk you through a couple of these. So for this first one, I have log, and my base is 1/5, and I'm taking the log base 1/5 of x, and I'm figuring out what y is. And I want you to remember, please, that y is going to be the exponent that makes it true. So if I put a 5 in where x is, that's the log of 1/5 of 5. So if I take 1/5 and I raise it to the negative first power, that will give me the number 5. So I have 1, 2, 3, 4, 5, and I go down to -1. So that's an ordered pair point that's on here. Now, we like to think of these in terms of smaller numbers are better, but that doesn't always work with this, okay? So if I put a 1 in there, then I have log base of 1/5 of 1. So if I take 1/5 and I raise it to the 0 power, that will make 1. So I have 1, 0 is another ordered pair. So once I have these 2 ordered pair points, I can see that this graph is going to look like this. Now, if I look, that took care of this first one. So if I look at D, this is going to be that graph reflected across the x-axis, reflected over the x-axis, which is going to keep this point where it is, and then this one won't be at 5, -1, it'll be up here at 5, +1. So that graph will do that. Now the other 2 are not as connected as those 2 are. Those have the same base. The next 2 do not have the same base. So we're going to go down just a little bit and do the next 2. So as we go through these next 2, I'm again going to be choosing x's to plug into log base 4 of x. And as long as you're careful about how you choose these, the ordered pair points are not hard to find. So since this is a base of 4, I want to work with bases that are 4. So I'm going to use a 4, and I'm in general always going to use a 1. So if I have log base 4 of 4, then I can look here and think of this as like an equal sign. So 4 to what power will make the number 4? So that's going to be a 1. So we'll be at 4, 1. So we've got that ordered pair point. And then for the next one, I have log base 4 of 1. So you can, again, think of this as an equal sign. Well, 4 to what power makes 1 happen? So that would be a 0. So 1, 0 would go here. So this graph goes in this direction. Now, when I look at this next one, I have a log base 3 of x, but we have this negative out here. So again, I'm choosing my x's carefully so that I can tell where this thing is going. And I'm going to always choose the base that's there, so I keep a 3. And then I'm going to put a 1 in there. So this time I just have to make sure at the end that I multiply by the negative that's out front. So I know that 3 to the first power is going to make the 3 that I need, and then I have to multiply by this negative. So on this one, I'll do it in red on that same graph. I've got 3, -1, so that's going to go here. And then if I do negative log base 3 of 1, then I know that 3 to the 0 power is going to be equal to 1, and then this time multiplying by 0 doesn't change anything. So this ordered pair point, of course, is going to be at 1, 0. So this would be the log base 3 equation from over here. These next couple of questions are asking about domain and range, so you kind of have to have an idea of what's going on with these equations, and it's wanting you to think about the transformations that are happening. So I'm going to rewrite this one as log, we know that's a base of 10, so this is x plus 4. So I know that a log base 10 of x is going to start out and be at 1, 0, and then I would have 10, 1. That's where it would be originally. Now, that is if it didn't have the plus 4. So that plus 4 moves it 4 to the left. 2, 3, 4. So that black x-intercept moves back to here. And then the point 10, 1 is going to move backward 4. So it'll be at 6, 1 here. Now, you don't have to do these graphs. This is unnecessary. I was just showing you what's going to happen. So I know that from what I have diagrammed here that I would have my horizontal asymptote would be at -4. Okay, x equals -4 would be my vertical asymptote. So that, of course, is directly related to the domain. Now, the way we're going to do this is to take whatever I'm taking the log of, and I know that whatever I'm taking the log of has to be greater than 0. I cannot have raising any base to any power will never make a negative value occur. If you don't believe me, try some, because you can't find it. So this says that x is greater than -4. So the domain for this one, it does not include -4, but then it goes on forever, because this red graph would do this right here, and it would keep growing just very, very slowly. All right, so for the next one, what they're pointing out to you is that just because my base changes, okay, this one does not have a base of 10, this one has a base of 6, the overall shape of it still matches. So this is y is equal to log base 6 of x plus 4. And instead of being at the ordered pair point 10, 1, we would just be at 6, 1 in its parent location. And then I'm backing up 4. So just because this number has changed does not mean that the domain has changed. So I have to check and make sure that what I'm taking the log of has to be greater than 0. So x has to be greater than -4. And if you are particular and you want to have actual ordered pair points, you can go find those. I am indicating to you, however, that as long as you know that this is the the vertical asymptote, then you know that this has no other shape changes, so this does this. So then I know that the domain starts but does not include -4, and it goes on forever. And then the range, it keeps going down and it keeps growing up, but very, very slowly. So your range is every y value possible. For this next one, you are asked to write an expression a log of x plus b or a log of negative x plus b. So the first thing I've got to figure out is, do I have a reflection? So I'm going to put a couple of parent points on here. I'm going to do these in yellow so they show up really well. So in a parent graph of log of x, you would be here, and then you would be somewhere out here at 10, 1. Okay, so we're somewhere out here. We'll act like that's on there. So that's at 10 on the x-axis. So this is what this does. So if this is what I'm considering my parent graph, then to end up where the black graph is, I have to have had a reflection. All right. Now, the reflection is across the the x-axis. All right. I'm going to reflect that across the x-axis. So then I'm going to have an ordered pair point. Instead of doing 10, 1, I would be at 10, -1. So we would now be about right here. I'm going to erase what we don't need anymore. So these are not here. So now my graph looks more like it's in the shape that I need it to be in. So because I have reflected across the x-axis, then I know that A has to be a negative number. I have reflected across the x-axis, so A will have to be a negative value. All right, so then I'm looking at the fact, did I reflect it across the y-axis? So this one is in the proper shape, it's just not in the right location. So the next thing I'm going to do is notice that in this form, my vertical asymptote would be here, but I'm noticing that it has backed up to where it is here at -2. All right, so we have moved left 2 units. So I can start out with an equation that says f of x is equal to -a, and then I have log of x, and if I'm moving left, I will be adding 2. So the last thing I need to do is look and find my a value. So I'm going to erase everything that I have drawn on this graph so that we can focus on the graph that they gave me. I do not have to determine what kind of transformations have happened because I've already done that. So now I'm looking for an ordered pair point that this goes through. I do not want to use -1, 0. I need to choose a different ordered pair point. And I will encourage you to make this big enough so that you can see a good one to use. So the one that we are going to use is going to be right here at 3, -2. So we come back over to our equation and we are plugging in -2 where the x is. I know that a has to end up being a negative number when I finish. And then I have log of, my x value is 3 plus 2. So I have -2 is equal to -a log 5. Now, log 5 is a number that I do not know its value, and I do not want the decimal. You don't have to write these as decimals. So I know that log 5 is a number. I know that this negative indicates that I have a -1. So I'm going to divide by negative log of 5 on both sides. Negative log of 5. So negative divided by negative becomes positive. So I know that a is the number 2 divided by log 5. Now if you wanted to go find that decimal, you can. It is unnecessary. You do not have to find the decimal. So then I'm going to take this value and I'm going to plug it in right here for A, and this is going to give me my answer. So my final answer is f of x is equal to -2 over log of 5. And then I have, that is A right there. So then I have log of x plus 2. Now, this feels very awkward to students. They do not like leaving it like that. You all want that to be just a regular plain number, and sometimes it will be, but this is also a number. So this, although strange looking to you, this is also something that you can have. See me with questions.